Hi, in this podcast we're going to talk about another gas law, which is Charles's law. Charles's law states that the volume of a gas is directly proportional to the temperature, and we can extrapolate this all the way back to 0 at 0 Kelvin. So pressure is constant. The equation is V1 over T1 equals V2 over T2. I don't like dealing with nonlinear equations, so I'm going to modify this equation by cross-multiplying the t's off the bottom so that it's all in one line. So you get V1 T2 equals V2 T1. That's the way I'm going to work with the equation throughout class and the podcast. Here we see the molecular level view of a gas particles in a box, and to talk about Charles' law, which talks about the relationship between volume and temperature, we'd need to hold the pressure constant. So in order to talk about these, let's lower the temperature and see what happens to the volume of the box. So the volume of the box is a little scuba guy, and he's going to make the box, looks like he's making it smaller. So with the decrease in temperature, we have a direct decrease in volume as the box got smaller. And we see that temperature increases, the molecules are moving less, and therefore they require less room to move around, so the volume of the box can decrease. Now if we would like to see an increase in the volume, okay, so the box back this way, we would need to increase the temperature. So if we make these molecules move faster, you see that the volume of the box starts to increase. So the little scuba man, he starts to move the box so the molecules have more room to move around. So just make sure you keep that in mind when you're thinking about Charles' law and volume and temperature relationships. All right, here is another graph. We have volume and temperature, and we see that it extrapolates back towards 0. Now 0 is negative 273.15 degrees Celsius, so 0 Kelvin. And you see that the two that are closest to that are He and CH4. And then H2O and H2 have a little bit harder time getting there. So we'll talk about more about why those deviate from ideal behavior later. All right, so practice problems. What would the final volume? So final volume would be V2. So we're looking for the second volume B. If 247 milliliters, okay, so this is this, of gas at 22 degrees Celsius, so this is our T1, is heated to 98 degrees Celsius, which is T2. Now, you always have to have your temperatures in Kelvin. It's one of the rules of the gas laws. So we're going to add 273 to our Celsius to get our temperature in Kelvin. So our T2 is 371 and our T1 is 295. All right, now that we have everything in the correct units, we can just plug it into the equation. So we have V1 T2 equals V2 T1, and we're looking for V2. So V1 was 247 times our T2, which is 371, is equal to our unknown times 295. All right, so we're just going to do a little multiplication. So this times this will give us 91637. And then you want to get your V2 by itself. So you're going to divide by 295 on both sides. And that gives you the solution for V2. So that gives us 310.6. Okay, we need a sig fig, so we got 3, 2, and 2. So 2's our smallest. So this is not going to round up because this is 0. But remember, you have to keep this one because it's a placeholder. So our sig figged answer is 310. And volume, our volume unit that we were dealing with in this problem was milliliters. Okay, so there's your answer. All right, time for one more practice problem. Okay, at what temperature would 40.5 of liters of gas, okay, so this is our V1, have a temperature of 23.4, so this is our T1, have a volume of 81.0 liters, okay? So this is our V2. Okay, so it wants to know at what temperature would this gas that's at this temperature be this volume, okay? So we're looking for our T2. Now, of course, we have to get our temperature straight, so we're going to add 273. That's going to give us 296.4 Kelvin. Okay. All right, now we're ready to plug into our equation V1 T2 equals V2 T1. All right, so V1 is 40.5. We're going to multiply that by our T2, which we don't know, is equal to our V2, which is 81, times our T1, which is 296.4. All right, now it's just a little math. So this times 296.4 gives us 24008.4. Okay, and that's equal to the 40.5 T2. Now divide by 40.5. Oops, on both sides. If my pen will work correctly. All right, so T2 is 592.8. Okay, now sig fig, we got 3, 3, 3, so we need this to be 3. So we'll go behind the third one, look it, it's going to make it round up to 593. And unit for temperature, well, remember we converted this one to Kelvin, so it's Kelvin. All right, and that's it. That's how you solve Charles' law problems.